Good morning, students. So today we can start our third module, and the syllabus is like this. It mainly deals with the bearing capacity of shallow foundation. Then the theory, in order to explain the bearing capacity, is Tersagh's bearing capacity theory, and the Tersagh's formula for different types of footings and its problems. Then last portion, total and differential settlement and its causes and methods of reducing differential settlement, and some soil improvement methods. Okay, so these are under our module 3. So first we can start what is bearing capacity of a soil. So all of you know that the basic structure of any building is foundation. Okay, so if foundation fails, the entire building will fail. Okay. And this foundation finally rests on our soil, that is the entire building load is finally transferred to the soil. So if the soil is weak, the building will fail. Okay, so if the soil is weak, we have to provide the type of foundation which can withstand that type of load. Okay, so before constructing any structure, we have to find the property of soil, so that we can decide what type of foundation is to be adopted. Okay, so when we are designing the foundation, the property of the soil which is to be taken is bearing capacity. So bearing capacity of a soil is the most important of all the topics in soil engineering, because based on this bearing capacity of soil, we are choosing the type of foundation. So if the foundation is strong, the entire building will stand for so many years. Okay, so this bearing capacity of a soil is very important as a foundation engineer is concerned. Okay, so in geotechnical engineering, bearing capacity is the capacity of soil to support the loads applied to the ground. So bearing capacity is nothing but the capacity of a soil to support the load which is coming from the superstructure. That is known as bearing capacity. That is capacity of soil to support the loads of the building. Okay, and the bearing capacity of a soil is the maximum average contact pressure between the foundation and the soil, which should not produce shear failure in the soil. Okay, so that is known as bearing capacity. So it is the maximum average contact pressure, that is force per area. This will be maximum average contact pressure between the foundation and the soil, such that there should not be any shear failure. Okay, so that is known as bearing capacity. And the soil behaves in complex manner when loaded. So it's important to know the bearing capacity of soils. We cannot predict the behavior of soil because it's a complex structure, it's a natural structure. So at least we have to analyze the bearing capacity of the soil. So by knowing the bearing capacity of a soil, we can design the footing. Okay, so as I told, bearing capacity is one of the important property of soil. And the term bearing capacity of a soil is used to indicate the maximum load per unit area which the soil will resist safely without displacement. Okay, so this is the footing. So this footing transfer, this is the load coming over the superstructure. So this is the load of the superstructure, that is the building load. So this load is transferred to the footing, and the footing is resting on our soil. Okay, so this is the contact between the foundation and the soil. So this is the pressure bulb, that is up to this depth the effect of this load will exist. Okay, so up to this area the soil should be strong. If the soil is very weak, we have to adopt deep foundation. Okay, like that we have to choose the type of foundation based on the property of soil. Okay, next, importance of soil bearing capacity. So the stability of a foundation depends upon the bearing capacity of the soil beneath the foundation and the settlement of soil beneath the foundation. So when we are designing a foundation, we have to consider two factors, that is the bearing capacity of the soil and the settlement of the soil. That is, the bearing capacity should be such that the soil should not fail under shear. Okay, and the settlement of the soil should be within permissible limit. So this is the two main important condition we have to adopt when we are designing a foundation, that is the bearing capacity of the soil beneath the foundation and the settlement of the soil. And there are two independent stability conditions to be fulfilled, since the shearing resistance of the soil provides the bearing capacity. That is, bearing capacity is low means the soil will fail under shear. Okay, that is, the bearing capacity actually indicates the shear strength of the soil. that is the ability to resist the external force, that is the shearing resistance of the soil provides the bearing capacity. And the consolidation property determines the settlement, that is if the settlement is very low means the consolidation is very low. So you have studied what is meant by consolidation. Okay. So in brief, the two important parameter which is to be considered while designing a foundation is the bearing capacity and settlement. That is, the bearing capacity should be such that the soil should not fail under shear, and the settlement should be within permissible limit. Okay. So these are the two important points while we are designing a foundation. So before going to the foundation design, we have to familiarize some terms related to bearing capacity. There are some definitions. You have to by heart all these definitions. You should thorough about these definitions and the relationship between all these parameters before going to our design portion. Okay. So first one, ultimate bearing capacity. This ultimate bearing capacity is indicated by the letter QU, Q suffix U. Okay. The ultimate bearing capacity is the gross pressure at the base of the foundation at which the soil fails in shear. So it is the maximum bearing capacity at which the soil fails. That is, when the soil exceeds this ultimate bearing capacity, it will fail under shear. So it is the maximum bearing capacity at the base of the foundation at which the soil fails in shear. That is known as ultimate bearing capacity, represented by QU. Okay. So next definition, net ultimate bearing capacity. So I have told that this bearing capacity is related to shear, that is shear strength or shear resistance. So when you are explaining this definition of bearing capacity, it's ultimate bearing capacity or net ultimate, etc., there will be the term like the soil fails in shear. Okay, that is, if this parameter exceeds the permissible limit, the soil will fail under shear in the case of bearing capacity. That is, bearing capacity is related to shear. So you should note this. This ultimate bearing capacity means the ultimate bearing capacity is the gross pressure at the base of the foundation at which the soil fails in shear. Next is net ultimate bearing capacity. Net ultimate bearing capacity is the net increase in pressure at the base of the foundation that cause shear failure of the soil. Okay, that is, this is nothing but net increase in pressure at the base of the foundation which cause the shear failure of the soil. Okay, so when we are calculating this net ultimate bearing capacity, that is, we can have this figure. That is, when we are finding out the net ultimate bearing capacity, we have to reduce this portion. That is, this portion means here there will be soil. Okay, so there will be the pressure due to this backfilled soil or this soil between this structure. Okay, so we have to reduce this portion, that is, the pressure exerted by this soil have to be reduced from the ultimate bearing capacity when we are calculating net ultimate bearing capacity. Okay, so that pressure, the pressure exerted by that backfilled soil is known as overburden pressure. So we have to minus this overburden pressure from ultimate bearing capacity QU. That is, QU minus gamma dF is the net ultimate bearing capacity. Gamma means it is the unit weight of the soil. Okay, that is, this is nothing but a vertical stress or the overburden pressure. That is, overburden pressure is equal to unit weight of the soil into the pressure, the height of this foundation, that is depth of foundation dF. Okay, so so that is equal to QU minus gamma dF is the net ultimate bearing capacity. So net ultimate bearing capacity is equal to ultimate bearing capacity minus overburden pressure. Overburden pressure means the pressure exerted by this the overburden soil. So that will be equal to unit weight of the soil into depth of foundation dF. Okay, depth of foundation means depth from the ground level to that of the footing. So that is known as net ultimate bearing capacity. The next definition is net safe bearing capacity, which is represented by QNS. So when the term safe comes, we have to impart factor of safety. So this factor of safety, I think you have studied in your design. Okay, TSS. So this net safe bearing capacity means the net soil pressure which can be safely applied to the soil considering only shear failure, that is without the shear failure. That is the net soil pressure which can be safely applied to the soil without having shear failure, that is known as net safe bearing capacity. So when we are calculating this net safe bearing capacity, we have to introduce this factor of safety. Okay, that is net safe bearing capacity QNS is equal to net ultimate bearing capacity divided by factor of safety. Okay, so what is net ultimate? QNU. QNU means QU minus gamma DF. Okay, QNU means QU minus gamma DF. So this QNU divided by factor of safety, when we are dividing the net ultimate bearing capacity by factor of safety, we will get net safe bearing capacity. Okay, so QNS is equal to QNU divided by factor of safety. This factor of safety will be 2 or 3. Between 2 or 3 we are putting the value factor of safety, or 2.5, 2 or 3. Next is gross safe bearing capacity. Gross means the total. Okay, so it is the maximum pressure which the soil can carry safely without shear failure. So gross safe. So here also the factor of safety becomes, that is QS means QNS plus this overburden pressure, because when we are taking the gross safe bearing capacity, we have to consider the overburden pressure also. So we have to add this overburden pressure with net safe bearing capacity in order to get the gross safe bearing capacity. So gross safe bearing capacity QS is equal to net safe bearing capacity plus overburden pressure. Okay, so net safe bearing capacity is QNU divided by factor of safety. So here we can write this equation like QS is equal to QNS plus gamma DF, and QNS is equal to QNU divided by factor of safety. Okay, so that is gross safe bearing capacity. So these are the definitions based on bearing capacity. That is, I have told that when we are designing a foundation, we have to consider two parameters. First one bearing capacity, second one settlement. So by considering these parameters, we have to design foundation. So first one bearing capacity we have discussed the definitions based on bearing capacity parameters in terms of bearing capacity. So next is settlement. So the parameters based on settlement is net safe settlement pressure and net allowable bearing pressure. Okay. So net safe settlement pressure means it is the net pressure which the soil can carry without exceeding allowable settlement. In previous one, in the case of bearing capacity, the definition comes without having shear failure. Okay, so here it means net safe settlement pressure means it is the net pressure which the soil can carry without exceeding allowable settlement. That is, this settlement should be within permissible limit. So within that permissible limit, the pressure carried by the soil is known as net safe settlement pressure, that is QNP. Okay. That is the definition based on settlement. Then last one is net allowable bearing pressure, QNA. And this net allowable bearing pressure is a parameter which is based on the settlement parameter and bearing capacity parameter, and this one is used for design purpose. That is QNS is equal to that is net allowable bearing pressure represented by QNA. And this QNA is equal to QNS, that is net safe bearing capacity or net safe settlement pressure. It may be equal to net safe settlement pressure QNP or QNS. What is QNS? Net safe bearing capacity. Okay, so that is net allowable QNA is equal to NA is equal to QNS if QNP is greater than QNS. That is, QNP means net safe. If the net safe bearing capacity is greater than QNS, this QNA, net allowable bearing capacity, is equal to QNS. And if this QNS is greater than QNP, if QNP is lesser value, this QNA is equal to QNP. That is, the lesser value is taken as the net allowable bearing pressure. That is, net allowable bearing pressure QNA is equal to QNP or QNS. So the minimum value is taken as net allowable bearing pressure, that is QNS or QNP. The minimum of this QNS or QNP is taken as net allowable bearing pressure QNA. So this is also known as allowable soil pressure. Okay. So these are some definitions. So you should by heart this one. You should read the textbook. If you have any doubt, you can ask me by WhatsApp or by call. Okay, thank you.